Hello everyone, my name is Baikatullah, number metric 2300473. Today I'm going to show you my program for calculating the average of four 16-bit number in assembly. First of all, we're going to do a memory address. So how we going to do it? You just click on the build disk button. So it appear at the bottom and say build successfully. After that, you just go to the debug, and at the top left you gonna see a memory or a place to place your memory. So the first one, we're gonna put data because that's our main point. And for the type, because I use SASM, which is usually we use hexagon. And for the type, I choose W, and array size for my content. And after that, a result. For a result, we also use a hex and also W and also array size only one. That's for our memory. So before that, on my program, I would like to show the output in my right box. So what you will do if you want to see your output is you need to write comment. This a simple comment which is modulus. Modulus include okay, this for library I think. So if you see before the system called exit, you need to put a comment to make this program print your output, so you can see what output you have. So the comment will be print x to result. So this is just a two basic comment for you to show the output when the program finish. Okay. So now after we have memory for our program and some command to display our output, we can now jump to our process on assembly. So firstly, EX is clear. ECX is set to 4 because there are 4 value, and ESI starts at 8, which is byte size of data. So for my loop, okay, I will try to run it first. If you want to run, just go debug like before and just click this repeatedly, step over. So it will run. You can notice the change on the register. So I will try to click first. So after I run first, you see that there is change at EIP, which is it mean plus 2. So after that, you can step over again to the next instruction. So now there is change on EIP and eFlex, which is EIP now it become main plus 4, and eFlex it become PF, ZF, and IF. So again, on the instruction which is set offset to 8, now we have a main plus 9. So on the AW section, which is firstly it will decrement SI by 1, which you can show the value of SI is now 8. After this, it will become 7 because it is minus 1. So if you proceed to the next step, the SI will become decrease and the value AW will plus 2. And then we will notice the changes on the EIP, which is it become AW plus 10 because addition is about loop to label and AW, and you have a formula which is CX equal to CX minus 1. So after that, This there's a looping, so we go up to the first one, which it will decrement value of si by 1. So now 6. After that, it will become 5. And again, loop, AW will plus 1. So the value of si will decrease by 1. It become 4. And AW plus 2. And it will become same because it is loop. So your value si become 4 and AW become AW plus 4. So now it will loop again. And the value of si remain 4 until I go to the next step. So now your value of si become 3. As usual, your EIP is AW plus 1. So value of si is 2 and AW plus 2. It will just be the same because it is a loop. So now we come to the bottom part, which is your SI value 2 and your EIP is AW plus 10. So again, we look again. So it become same, which is SI will drop and AW will increase, I think. See the notice on the SI. So when SI hit 0, we will go to the exit part, which is the looping is end. So the system we call a kernel, and then when you step over, nothing happen. Step over and the debug is stopped. And then we show debug is finished, and you will get your output, which is 2800. And it have a new thread 6488.0x619C. So that's all from me. Thank you.